So welcome everybody to this latest video on 162 Maths, and in this video we'll be continuing with the series of going through some big mark questions taken from some high GCSE exam papers. Now, as always, I'll include a copy of the questions in the description below so you can have an attempt at the questions before watching through this video as we go through the answers. Now, before we get started working through these questions, it's worth reminding that when we go through these questions, we're not actually going to be going through each of these particular topics in great detail. Now, if you're not sure about any of these topics, then I strongly recommend you go back and revise either through what you've done in class or your exercise book or revision guides. But I'll also include a link in the description which takes you to lessons which I've covered these particular topics in much greater detail. So getting started on question 1, it says use trigonometry to work out the value of x. Now for this we just need to make sure that we recognise that the triangle isn't usually in the right orientation of what we usually expect with trigonometry questions. So to make this question a little bit easier for you to understand in terms of the labelling, what you may want to do is just turn this triangle onto one of its sides so that we've got the angle here of 58, this side here is being 46, and this side here, which is what we're trying to find. Now when it comes to labelling, we need to make sure we label the sides correctly. So x is going to be our opposite, the 46 is going to be our adjacent. And again, depending on whether you've chosen to redraw the triangle, it's entirely up to you. Now in terms of working out the trig ratio that uses opposite and adjacent, we're going to be using tan. So the formula is tan theta equals opposite over adjacent. And again, always good practice to kind of write down the trig ratio that you're using, just so that when you then go on to substitute the values in, you can see exactly what it is you need to do. So here we've got x over 46. So that means that x is going to equal 46 multiplied by tan 58, which if I stick into my calculator gives me an answer of 73.6, and that's to 1 decimal place. Moving on to question 2, it says that Millie is estimating the value of this calculation, and it says she rounds each decimal number to one significant figure. Work out Millie's estimate and you must show your working. So for this, what we need to do is take the decimal numbers, and what we need to do is we need to round each of these numbers to one decimal place. So rewriting this, what is it going to look like? Well, it's going to look like 1, well actually let's not put an equal sign because we're going for approximations. So it's going to look like 1 over, and then it's going to be the cube root. Now, if we round 8.34 to one significant figure, that's going to be the cube root of 8. That's all being squared times, and the rounding of 10.21 to one significant figure is going to give us 10. Then from this, we can then work this out. So it's going to be 1 over the cube root of 8 is 2, so that's going to be 2 squared times 10, which is equal to 1 over 4 times 10. Which is equal to 1 over 40. Now the question is saying that we need to give our answer, well it doesn't really say how we need to give our answer. We can either leave the answer as 1 over 40, or we can write it as a decimal, which is 0.025. So any of those two answers would be absolutely fine for the 2 marks. Then moving on to B, it says Millie says that my estimate must be more than the exact value. Without working out the exact value, give a reason how she can know this. Now for this, there are several answers in which you can give that will give you the 1 mark for this. So you can either say that the denominator is smaller, the denominator using the exact values is bigger, the decimals have been rounded down, because 8.34 is more than 8 and 10.21 is more than 10, 1 is divided by less than the answer, which is more. Estimating rounded numbers, which makes the denominators less, is going to be all valid explanations. So in terms of this, what we're going to write down is something along the lines of the exact answer will be smaller as smaller values were used, and so therefore the denominator will be bigger. And again, what you need to remember is, like, so if I had 1 over 2 and 1 over 3, the bigger the denominator, the smaller the value. So that's just something you need to bear in mind, something along those lines. But one thing you don't want to do is actually compare it to the actual answer. So if this question did appear on a calculator paper, one thing you definitely don't want to do is to actually work out the answer, because it does specifically say without working out the exact value. Moving on to question 3, it says here is a buy spinner. Ali, Ben and Carrie want to know the probability of spinning red on a buy spinner. They each spin it and count how many times it lands on red and divide by the total number of spins. Ali says that I spun the red the most times. Ben says that I spun the spinner the most times, and Carrie says that my relative frequency of red is 0.25. Who had the best estimate for the probability of spinning red? And you need to give a reason for your answer. Now for this, because this is a relative frequency answer, I would probably assume that most people would say Carrie was correct, because you can see from the diagram that that's going to look like a quarter, even though there's no proof that it is a quarter because there's no box there to know that that is going to be a quarter of a spinner. And you'd probably say that because it's a quarter as a decimal is 0.25, so Carrie must have the most accurate answer. But actually, with this being relative frequency, it's actually the more number of trials that gives you the most accurate probability. So for this here, we need to say that Ben, it gives the best estimate because he spun, because he spun the spinner the most. And there we go for that 1 mark. Then for B, then says that Dev spins the spinner 80 times, and he says that his relative frequency of red is 0.185. Give a reason why his relative frequency must be wrong. Well, if he spun 80 times and his relative frequency is 0.85, if I do 80 multiplied by 0.185 and I type that into my calculator, I'm going to get an answer of, and let's just quickly work that out. So I've got 80 multiplied by 0.185 gives me an answer of 14.8. Now, if that is his relative frequency, this is a decimal, so this is a number of reds. And as you can see, it's a decimal answer, which you can't have. So that's where it's going to be incorrect. Moving on to C, it says Elena spins the spinner 125 times. The relative frequency of red is 0.32. Work out how many times the spinner landed on a green. So for this, there's a number of ways in which you can do this. So let me just split this up. So you can either do 1 minus 0.32, which gives us 0.68, and that is the relative frequency for the green. And then we just need to do 0.68 multiplied by 125. And again, if I do that on the calculator, 0.68 gives me an answer of 85 times. Alternately, what you could do is do 0.32 multiplied by 125, which gives me an answer of 40. So that's 40 red. So then the number of green is going to equal 125 minus 40, which again gives me 85. So any of those two ways would be valid for the 2 marks. Moving on to question 4, it says that Charlie is driving 293 miles home. He leaves at 9 a.m. He travels the first 176 miles at an average speed of 48 miles per hour and drives the rest of the way at an average speed of 65 miles per hour. And the question is asking us, will he be home for 2:30 p.m? So for this, what we need to do first is work out the time and distance and speeds at traveling at each of those times. So if I just label the 2 parts of the journey, so I'm going to label this as A and label this second part as B. So here, if we work out the time of A, which is the thing that I need because obviously that's what I'm comparing. So again, remember that we've got distance, speed, time. So to work out the time, I need the total distance. So the time equals the distance divided by the speed. So we know that the distance is 176 and it's in miles, and we need to then put the speed in miles per hour, so that's going to be divided by 48, and if I type that into my calculator, I'm going to get 3.6 hours. Now obviously I need to convert that into hours and minutes, so if I multiply that by 60, that then becomes 220 minutes, which I can then convert into hours and minutes, knowing that 60 minutes is in an hour. So this is going to be 3 hours and 40 minutes. And let's just highlight that for when I come back to it. Now the next thing I then need to do is work out the time of B. So for the time of B, again, we know that we then need to work out the distance, because at the moment all I know is the speed. So the distance is going to be 293 minus the distance travelled in A, which is 176, and that comes up to a total of 117 miles. Then, using the same sort of thing as I did for the time for A, so the time then is going to be 117 divided by the speed, which is 65, and that comes up to a value of 1.8 hours. So then if I multiply that by 60, that's going to equal 108 minutes, which then if I then convert that into hours and minutes is going to equal 1 hour and 48 minutes. Let's just highlight that. So then what we then need to do is then work out the total time. So the total time is going to be 3 hours 40 minutes plus 1 hour and 48 minutes, which comes up to a grand total of 5 hours and 28 minutes. So then going back to the question, it says, will he be home for 2:30? Well, if he leaves at 9 a.m, so if I then do 9 a.m. plus 5 hours and 28 minutes, it comes up to a total time of 14:28. So will he arrive home before 2:30? The answer then is yes, only just by 2 minutes. Moving on to question 5, it says that Kieran paid income tax and national insurance on her annual salary. The income tax is basically calculated by doing 0% of the first £12,570 of her annual salary, and then 20% of the rest of her annual salary is therefore going to be classed as income tax. For national insurance, 0% of her first £9,880 of her annual salary is not taxed for national insurance rather, and 13.25% of the rest of her annual salary is then taxed and classed as national insurance. Kieran paid £5,186 of income tax, and the question is asking us to work out how much national insurance she paid. So let's have a look at this particular question. Now the first thing we want to do is work out what her annual salary is. So for this, her total pay. Now if 5,186 is basically 20% of the rest of the taxable income, so we know that 5,186 is equal to 20%, so therefore 100% is going to equal 5,186 multiplied by 5, which comes up to a total of 25930. Now for this we then need to add the amount that wasn't taxed, so we add 12,570 to that, in which giving Kieran an annual salary of £38,500. Now once we know this value, we can now use the information in the second box to work out the national insurance. So for here, the national insurance is going to be, well, first thing I need to do is work out take off the 9,880, which is the tax-free amount. So it's going to be 838,500 minus 9,880, which comes up to a total of 28620. Now from this, what I then need to do is then work out what 13.25% is off this amount. So here we then want to work out what 13.25%, don't know what happened there. Percent of 28620, and to do that you need to do 0.1325 multiplied by 28620, and typing that all into my calculator gives me an answer of £3,792.15. Moving on to question 6, it says that 180 runners started a marathon. Some of the runners did not complete it. The histogram represents the times of the runners who did not complete the marathon. And the question is asking us of how many runners did not complete the marathon. So for this, what we need to do is we need to work out the frequency of each of the bars. Let's just reset. So let me just go back to the question. And there we go. So what I need to do here is I need to work out the frequency of each of those bars. Now remember that the frequency is equal to the area of the bar. So for this bar here, let's just call that number 1. So number 1, the height is, I would say, it's going to be 0.8 multiplied by the width, which using the scale is 20, and that comes up to a value of 16. Then for number 2, so number 2 has got a height of, I would class that as being 1.8, and again multiply that by the width, which is 20, and again working that out gives me an answer of 36. Then for number 3, again the height of the bar using the scale is going to be 1.2, and we multiply that by the width, which from 220 to 180 is 40. And again, working that out gives me an answer of 48. Then for 4, again, the height of that bar is going to be 0.7. Multiply that by the width, which is 40 again, which comes up to a value of 28. And then finally, for bar 5, that's got a height of 0.4. And we multiply by the class width, which is 60. And that gives me an answer of 24. So all that's left for me to then do is add up those frequencies, in which I'm going to get an answer of 152. Now the question is asking how many runners did not complete the marathon. So, and here the graph shows the runners who did complete the marathon. So the number of runners not completing is going to, which is then 180 minus 152, which gives me an answer of 28. Then moving on to the last part, it then says the table shows information about runners who did not complete the marathon. And here it gives us the least distance, the greatest distance, the lower quartile, the median, the interquartile range, and the question is asking us to draw a box plot to represent the information. Now the only thing that's missing here, so if I just mark down each of these values, so the smallest distance is 5, so I'm just going to draw a line at 5. The greatest distance is 23, so I'm just going to find 23, and that's going to be there. And then the lower quartile, which is at 11, so that's going to be there. And then the last bit, the median, is 18, so that's going to be 4 away from 20, so it's going to be there. And then all that's left for me to then do is work out the upper quartile. Let's work out the upper quartile. The upper quartile is the lower quartile plus the interquartile range, which is 9, so it's going to be 11 plus 9, which is 20. So the upper quartile equals 20, and that's going to be just there. Then all that's left for me to then do is turn this into a box plot. Now again, a little reminder that you should be using a ruler and drawing this as accurate as possible, but obviously with the commutes can be rather difficult, but your box plot should look something like that for the 3 marks.